Hello, this is Dr. Arabic, and I'd like to welcome you back to our course Introduction to Reinforcement Learning Motion Control. The topic of our lesson is the types of machine learning in motion control. We'll start with a general description. The three types are supervised learning, unsupervised learning, and reinforcement learning. Supervised learning can be viewed in a simple way as curve fitting. In other words, we have labels with which we can specify the input and the output. We then draw the best fit. And once we get a new label, we can use the best fit to find out what will be the output. When we have unsupervised learning, we actually do not have labels, but we find characteristics of each one of the input parts, and then we group them together to differentiate the two. So we may use it to find good parts versus bad parts. And then reinforcement learning is a little different. What it does, it actually provides the system a way to make decisions. It is using a reward function which describes the intended output of the system. Like, for example, a reward could be a bone or some food to a dog when we teach him how to sit. And then the machine learns from a series of actions where it fails and succeeds how to do it. In general, supervised learning is labeled data. It gets direct feedback with the input and output, and you can predict outcome for the future. Unsupervised learning has no labels, it has no feedback, and we find hidden structures in the data. And reinforcement learning is a decision-making process. It is having a reward function and also learn a series of actions by trial and error. Let's take a closer look at two main machine learning technologies which are used in motion control. The supervised learning in motion control is used for smart sensing. For example, we have labels, cats and dogs, and then we feed in the features of these labels, which could be RGB of each one of these little squares. There could be hundreds of them, into a neural network, which has several layers. Each one of layers has a neuron, and they having synapses to connect between them with signals. When we have a certain label, the features or the value of each label, which could be the total gray or RGB, is fitting into each one of the input layers. And then each one of these input layers is filling each one of the next layers. Now, the connection between them are the parameters, the neural network parameters. And the whole process of learning is actually, like we do in PID, tune the three parameters. Over here, we may have to tune hundreds of parameters. All these W's will have to be, which is the weighting function, will have to be trained in order such that the output will get the probability that what we see over here on the image is either a cat or a dog, or for autonomous vehicle, it could be tree, car, some kind of a traffic signal. And the summary is that the learning is the process of updating the weight, this weight, the parameters, such that when the features of the image in the question is fed as an input, the output will show the probability of being the same type as the label. In other words, once we train this system, then when we bring any feature in, it could be cat or a dog, we will get over here, if there was a cat, we'll get here that the probability of being a cat is like 95%, and the probability of being a dog is 5%. So this is very much used in motion controllers for vision. In other words, machine vision is going to sense the surrounding, and it's going to decide what it sees. And based on this information, it's going to feed it into a PID controller, and the controller will have a statement in the program that says that if you see a stop sign, then you have to stop the car. On the other hand, the reinforcement learning controller actually results in autonomous motion. And similarly to what we saw in a supervised learning, we have over here a neural network. But the input to the neural networks are not images. The input are actually states, like, for example, desired position of the robot or the rocket or the car, actual position, velocity, force, vibration, temperature, all are being fed from the system as the feedback sensor, exactly like in a PID system. But then we have hundreds of parameters, the same way as reinforcement learning is doing, the same as supervised learning. And after we optimize all these weights, the so-called tune them, then the action is going to be for each actor, what's going to be the motor power of first motor, second motor. It could be many other actuators, such that we drive the SpaceX rocket in landing to a perfect position, and make sure that the humanoid is actually making the right decision when you see an obstacle, and the same thing with autonomous vehicles. So these are basically the main difference. We see more of the insight of these features as we go along. And at this point, I'd like to thank you for listening and look forward to talk to you in our next lesson. Thank you.